Hi, so today we'll be working on the first part of 4.2, and we're going to talk more about angles. So if you have a ray like this, and if you clone that ray, and if you start to rotate the ray, you create an angle. The angle is created when the endpoints of the two rays connect, and we call that the vertex. And it is created when we open up one ray, and they're sort of like offset a little bit. So if we do rotate a ray, that ray that we started with, this one, that is called the initial side. And the final position of that second ray will be its terminal side. Now, if I get a ray and if I anchor it on the X and Y axes, then I make a ray or an angle in standard position. For that to happen though, two things have to happen. The vertex has to be at 0, 0, and the initial side has to lie along the x-axis. Then I say the angle is in standard position. Now, when I start from the x-axis, I can rotate that second ray up and to the left like this. That's the counterclockwise direction. And when I do that, I create a positive angle. So when I rotate counterclockwise, I create a positive angle. When I rotate to the bottom clockwise, I create a negative angle. Here are some examples right here. And in the first case, my angle is in the counterclockwise direction, so that's a positive angle. Here I have a clockwise, that's a negative angle. Right. So angles are measured in degrees and in radian. All right. In the case of degrees, we know basically what that looks like. In one circle, there are 360 degrees. So if I take a pizza and slice it into 360 slices, each one of those will represent one angle. So it's a tiny sliver. Radian is a little bit different. To think about radian, let's look at this circle. Imagine this is a circular track and it has a radius of 10 meters. And imagine you're here and you are walking along the outside of this track for PE. Now suppose you have a pedometer or your phone that's tracking your steps and your distance. And suppose you walk a distance here. Suppose you walk 10 meters. You end up here. And when you end up over there, you create an angle. So if we were to take a ratio of how much you walked over what the radius of the circle is, well, you walked 10 meters and the radius is 10 meters. That's a ratio of 1. That means that angle that you created is 1 radian. So you see how different that looks from a degree. Whereas a degree was a tiny sliver, a radian is much bigger than that. We cannot fit 360 radian around a circle. All right, if we continue doing that, suppose you walked a total of 20 meters here. Now, the angle that you created, right? Let's see, if you walk 20 meters divided by the radius, which is 10, that's 2. So that's 2 radian. Now, suppose you start walking You get here and you kind of feel winded and you look and you say, oh, look, I've walked exactly half of the circle. And you look at your pedometer and right at that point, it reads that you have walked 31.4 meters. So let's see what that ratio is. You walked this much divided by 10 meters. That is 3.14. So that angle that you've created there, that is 3.14 radian, otherwise known as pi. So that's where pi comes from. If you walk the distance around half of the circle, the angle that you've created is pi. In degrees, we know that to be 180 degrees. And that fact is going to stay with us for the rest of this semester. That 180 degrees is equivalent to pi, because when you walk half the circle, you've made an angle of pi. So if you walk the entire circle, you cover 360 degrees or 2 pi. So we're going to use that red in order to convert back and forth between degrees and radian. And if we go here, it says to convert from degree to radian using that same fact. Anytime in math you have to convert units, you always start with what you have and you do times fraction bar. All right, in this case, when you do times and fraction bar, notice you have a spot below and a spot above the fraction bar. In those two spaces, you're going to put either the 180 or the pi. So this 180 and pi, each of those are going to go into one of those spaces. Okay, I start with 30 degrees. That's what I'm given. If that value 30 degrees is in the numerator, it's on top. That means the degrees go on the bottom here, and the other value just goes over there. So now we just have to simplify this. You can always cancel out equal number of zeros from the top and the bottom. So now I have 3 times pi over 18. Divide by 3, I get 1. Divide by 3, I get 6. And that gives me pi over 6. Let's do another one. Times pi over 180. All right, so what I'm going to do now is I'm going to divide both by 5. I divide by 5, I get 27. I get 36. So now I have 27 times pi over 36. Now I can divide by 3. Actually, I can divide by 9. I can divide by 9 and I get 3 and I get 4. So that is 3 pi over 4. Moving on to D, because C is very similar. Moving on to D, I do times. Pi goes on top, degrees go on the bottom. All right, same way. Equal number of zeros cancel. So now I get negative 27 pi. I get negative 27 times pi over 18. Okay, divide by 9, divide by 9, and I get negative 3 pi over 2. Okay, next we're going to go backwards. We're going to go from radian to degrees. Same situation, times fraction bar. What I have now is the pi on top, so it goes on the bottom here, and 180 up there. Okay, pi cancels with pi, so I have negative 2 over 3 times 180 over 1. All right, I can divide by 3, I get 1. Divide by 3, I get 60. So this is negative 120. Let's do another one. Times pi on the bottom, 180 on top. Pi's go away. Now, I can divide the 6 and the 180. I can divide the 6 by 6, I get 1. The 180 by 6, I get 30. So that gives me 7 times 30, 210. And same way, I could do the rest. All right, let's move on to coterminal angles. Coterminal angles are different angles that end in the same spot. So for example, suppose I have an angle of 20 degrees. That's how that looks. If I'm on the terminal side of that 20-degree angle, I can go around 360 and get right back to where I started. So that creates a coterminal angle if you just keep going back to the same terminal side. Now, how do you find coterminal angles? If they're measured in degrees, you add or subtract 360. If they're measured in radian, you add or subtract 2 pi. Okay, let's do an example here. Suppose I had an angle of 50 degrees. I can take the 50 and I can add 360 and get an angle of 410. Or I can take the 50 and I can subtract 360 and I get an angle of negative 310. So now look at this. The 410 and the negative 310 end in the same spot as the 50. But notice the red one is a positive number, the green is a negative number. Those are called a positive and a negative coterminal angle. So with radian, I have to add and subtract 2 pi instead of 360. So for my positive coterminal angle, I get my 2 pi over 3, and I want to add 2 pi. Well, I need to do a common denominator, right? And if the denominator here is 3, then I multiply this by 3 over 3. So I get that this is 2 pi over 3 plus 6 pi over 3, 8 pi over 3. For the negative, I get 2 pi over 3, and I have to subtract 2 pi. And again, I multiply by 3 over 3 to get the common denominator. So that's 2 pi over 3 minus 6 pi over 3, negative 4 pi over 3, right? So notice, for the positive coterminal angle, I get a positive number. For the negative, I get a negative number. Okay, let's do one more. I have negative 7 pi over 4. For the positive, I'm going to add 2 pi. Okay, the denominator is 4, so multiply by 4 over 4. I get negative 7 pi over 4 plus 8 pi over 4, 1 pi over 4. For the negative, I subtract 2 pi. The denominator is 4, so I multiply by 4 over 4. Negative 7 pi over 4 minus 8 pi over 4, negative 15 pi over 4. And that's my positive and negative coterminal angle. All right, so with that, you can go ahead and do the homework, and it'll be due for the next class.